Here we go. In this video, we're going to talk about systems of linear equations. Our goal is to determine if two lines in standard form are parallel, perpendicular, or neither. We're going to first go over the conditions of parallel lines. When we have standard form, we have an equation in the form of ax plus by equals to c, where a, b, and c are integers, and a should be a non-negative integer. In order to figure out if they are parallel, the first condition is they have to have the same slope. There's actually a second condition we need to be careful about, which is determining if they have different y-intercept. Because if they have the same slope and the same y-intercept, then they're actually the same graph. So we have to make sure they have different y-intercepts. The slope and y-intercept can be found by converting the equation to slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept. Note that there's a nice shortcut if we solve the general standard form equation. We have the slope m equals negative a over b, and the y-intercept lowercase b is equal to capital C over b. To just note that if b equals 0, then we'll have a horizontal line. Now let's look at the conditions for perpendicular graphs. In perpendicular graphs, we only need to focus on the slope. The slopes are negative reciprocals of each other, meaning if we took the slopes of both the graphs and multiplied them together and equals to -1, we will know they're perpendicular. Or in the negative reciprocal form, it will look like the first slope is equal to -1 over the second slope. A quick example of slopes that are negative reciprocals from each other would be something as follows. If the slope of the first line of our equation, whatever it may be, is 2 over 3, and the slope of the second line, if it was -3 over 2, this would indicate that these slopes are negative reciprocal of each other. Alternatively, if we took the product of the two slopes, 2 over 3 times -3 over 2, and see if it equals -1, which it does because we'll have -6 over 6, which simplifies to -1. Then the other form of negative reciprocals is met. And so if we have slopes that are negative reciprocals of each other, we'll know that the graphs would be perpendicular. Now let's look at the last case, the neither case. The condition for neither is if the slopes are neither equal nor negative reciprocals of each other. The line are neither parallel nor perpendicular. And here's a summary for all the conditions to determine if two lines in standard form are parallel if the slopes are the same and the y-intercepts are different, or perpendicular if the product of the slope equals -1, or if the slopes are negative reciprocal of each other. And for the neither case, we're only focusing on slope. We just need to make sure that the slopes are not equal and they are not negative reciprocal of each other, meaning the product does not equal -1. These are the summaries of the conditions we're looking for. Now let's look at an example. Example 1. Determine if two lines in standard form are parallel, perpendicular, or neither. We're given a system of two equations where both our lines are written in standard form. So let's take the first line here, 2x minus 4y, and write it into the slope-intercept form. So we can clearly see what the slope is and the y-intercept to determine if it's parallel, perpendicular, or neither. With the first equation, we have 2x minus 4y is equal to 8. We'll subtract 2x to both sides of our equation, and we'll get the following. -4y is equal to -2x plus 8. Then we'll divide every term by -4, so we can isolate the y, ending with y is equal to 1 over 2x minus 2. So now we can figure out that the slope of the first equation, m1, will be 1/2, and the y-intercept of the first equation is -2. We're going to also do this for the Second equation, we have negative 2x plus 4 plus 4y is equal to 12. This time, we're going to add 2x to both sides of our equation and simplify. The left side will have positive 4y is equal to 2x plus 12. Then we'll divide every term by 4, leaving us with y is equal to 1/2 x plus 3. Now we can see that in the second equation, our second slope is 1/2 and our second y-intercept is positive 3. Let's quickly organize our information on what we just did. In our first step, we convert both equations into slope-intercept form. We want to focus on their slopes primarily. Now, in step 2, comparing our slopes. The slopes of both lines are m1 equals 1/2 and m2 equals 1/2. We have the same slope. Step 3, we want to compare the y-intercept. So our first y-intercept is negative 2. Our second y-intercept is 3. Now that we are sure that both the graphs are parallel because it meets the same slope condition, and they're not the same graph because it meets the condition to have different y-intercepts. Since all the conditions has been met, we can finally draw our official conclusion. The two lines are parallel because they have the same slope, m1 equals m2, which equals 1/2, but they have different y-intercepts, so they're not the same line. Our first y-intercept was negative 2, and our second y-intercept was 3. And that's it. We figured out that the two lines that were given to us in standard form were parallel.